One thing I wanted to show you on your calculators. It is absolutely not needed. You don't need to know how to do this. I would even say I wouldn't waste my time doing it. However, every single year on this test, there are always people who spend and waste a lot of time on their calculators trying to graph a vertical line on the screen. Okay, it's not needed. You don't need to do that. You need to be able to visualize it and just know that there is a vertical line there. But I want to show you how to graph a vertical line in case you want to do it. That way, if you want to do it, you can do it quickly and not waste 5 or 10 minutes before getting up. And what we'll do is I'll go ahead and start graphing. What were the graphs? The natural log of x plus 1?
No, it was square root x, and then e to the negative 3.
Wow, where was I getting natural log? Square. Oh, is that another one? Oh, okay. So the square root of x and e to the what? So e to the negative 3x. There we go. So there's that. Then there's also the line x equals 1, and you cannot graph an x equals in this screen where it says f3 of x equals. That's basically saying y equals. So you can do horizontal lines and just put a 4 there and graph y equals 4. Vertical lines, you have to change that entry line to something that accommodates x equals. And to do that, you hit Menu, Graph Entry, Edit. And right here, you have all of the options for the different different graphs we have. I don't know where that came from. So you have like parametric, polar stuff. We don't deal with that. There actually is a differential equations grapher where you can graph slope fields and things. It's cool, but not needed. That's why I never showed you. But the one we're going to use is relation. Relation allows you to type in any type of XY relationship. So you can do like x squared plus y squared equals 9 and graph a circle with a radius 3. You can do stuff like that. Or you could just do something like rel, by the way, displays like that, and you just hit x equals 3. When I do that, there's your vertical line. Oh, I don't know why I did 3. It was 1, wasn't it? Okay, so we'll just pretend I hit x equals 1. But that's how you would graph an x equals line if you wanted to. There's no need to do that. It's not necessary. And then if you want to go back to your traditional graphing entry, you hit Menu, go back to Graph Entry, Edit, swap back to Function, and that's where we graph our typical functions. Right. So if you want to do it, that's how I would say don't waste your time. Hopefully everybody was able to work through this problem without ever actually putting that on the graph calculator. It's just not needed. But it can be done, and so there you go. Let's see. Let's talk about some other warm-ups. We'll come back and talk about that problem in a minute. Let's talk about the one from Thursday. This is Wednesday. Okay, so F is always positive and increasing. I'm sure every single one of you wrote down F prime is positive as soon as you saw that F was increasing, because that is a true statement, right? Your brain needs to go there. If you thought about it, that's good. If you didn't think about it, no big deal, because it doesn't matter in this problem. So the region contained by that graph, the line x equals 3, maybe that's why I was thinking x equals 3 a second ago, and both axes. So what I'm going to do is I'm going to graph F. I don't know much about F other than F is always positive above the x-axis and increasing. So F looks something like that. There's my f of x. Here's my line x equals 3. And we're taking this region and rotating it around the x-axis. Every single rotational volume problem is going to be a disk or a washer. What is this one? It's a disk. There's no empty space between the region and the axis of rotation. A disk is a calculus word for circle. The area of a circle is pi r squared. And the radius, you always draw your radius from axis of rotation, from the axis of rotation to the boundary, which is up here. There's the radius, and that radius is determined by that function f of x. So we'll set up the antiderivative as pi all of f of x squared. You don't need the extra parentheses, but it looks better that way to me. Dx, and then limits of integration are 0 and 3. And that's it. Are we good? Cool. Look at yesterday's. Yesterday's was a lot scarier. Yesterday's was a lot worse. I did give you the nice little do not evaluate option. If you wanted to practice on your calculator, you could have, because you actually have equations this time. I didn't tell you which graph was which, but you should know that x squared plus 3 is the parabola that opens, minus 3x is the parabola that opens up. So that one is my x squared minus 3x. This one is your natural log of x plus 1. And they say cross sections. Here's the big sentence. There's a lot of information in this sentence right here. Cross sections perpendicular to the x. What does perpendicular to the x mean? It's a dx problem. Are rectangles. What does that mean? Yeah, the area of a rectangle is base times height. Then I give you a description of the height. The height is twice the base. That means h is 2b. Good. So far, with just that information, we can set up our antiderivative in extremely generic terms. The antiderivative of b times h dx. And then limits of integration. If it's at dx, we're going from 0 to 2. How do we feel? Right? Now, we're not done. We have to have our expression in terms of x. Right? So now we have to ask, what is the base and what is the height? Well, I could start, if I know that the height is twice the base, I can take that expression and plug it in for the height here. So now I have 0 to 2 of base times 2 base. And a lot of people left their answer in that format when they replaced the b's with the expression it's supposed to be. You can also turn that into 2b squared and pull that 2 out of the integral. Make it 2, 0 to 2 of b squared. Makes it just a little bit cleaner. Not necessary, but a little bit more convenient. But then I need an expression for base. And here's the last piece of information that's crucial. They tell you the base is the dimension that is in the region. So much information out of that one sentence. Basically, the entire setup is from that one sentence. When I draw my cross section perpendicular to the x-axis, the wording tells you that that is the base. So here's the base. And how do I get that dimension? Top minus bottom. The top is natural log of x plus 1. The bottom is x squared minus 3x. And I'll simply replace b with that expression, and that is our final answer. So the answer is 2, antiderivative 0 to 2 of natural log of x plus 1 minus x squared minus 3x all squared dx. And you can also, and several people did this, put your answer like this expression up here and replace both of those b's with that big expression. It's just a little bit uglier. It takes a lot longer to write. Good? Good. The other thing you could have done to make this a little bit nicer, and I don't think anybody did this. Maybe some people did, and I just forgot because I graded these really late last night. You could have decided to label these like let f of x equal natural log of x plus 1 and let g of x equal x squared minus 3x. And if you make those labels, if you put that in your work, then you can actually describe b as f minus g and make it a little bit cleaner for your writing later. Are we good? All right, let's talk about the warm-up from yesterday, 2022. How did we feel about this one? Half of it?
We didn't do that. The one we did yesterday. The one we did yesterday.
This is the sheet I gave y'all yesterday, and you were supposed to do this problem for homework.
You said warm-up.
Oh, did I say warm-up? Oh, I'm sorry. There's the confusion. Okay. I was like, what are y'all talking about? Okay, my bad. Okay, now for your response question. 2022, were y'all born yet? Yeah? 2 of the 4 should have been fairly nice. Is that safe to say? Question A was very nice. Area between 2 curves. You do have to do a little bit of work to find this intersection. They called it B, right? And that value is 0.782. Now, I would like for you, because that intersection is the upper limit here. If you didn't write, if you actually put the value, that's fine. I want you to write the equation that gave you that point. Show where you found the value of 0.782. Obviously, you're doing it on your calculator, but it comes from solving the equation f of x equals g of x. Good. And there's your setup, throw it in the calculator, and I got 3.6035. Good on A. Okay, I'm going to skip to C because that was the other part that was nice. C is your known cross-section question. perpendicular to the x-axis makes it a dx. We're looking at squares, so side length squared. And your side length is top minus bottom. So just be very careful with your parentheses that you do square the entire difference, because it's very possible that you have a very, very good understanding and you're very confident in this problem, but then you just forget parentheses somewhere in your calculator and you don't notice it. So A and C were the traditional area volume type questions. B and D, definitely part D, were not. Good. Can I go back to B? Okay, I think I already have B worked out, so I'm just going to talk through this one. Did y'all figure out B? Were we able to feel our way through it? Okay, so 3, or B, is a first semester question. Okay, they talk about H being the vertical distance between the graphs, so I drew H, the vertical distance between the two. And then they ask, is H increasing or decreasing? Those are first semester words. You should immediately think increasing, decreasing. That means they're really asking, is H prime positive or negative? Anytime you see the word increasing, decreasing, I would like for you to immediately think derivative positive, derivative negative. Now, sometimes it doesn't matter, like that warm-up I talked about earlier. I described f of x as an increasing function, and I would like for you to think f prime positive, but it didn't matter. Even if you wrote it down, you wasted a whopping 3 seconds. So it's worth thinking about. If you use it, it's great. If you don't use it, no big deal. In this case, we absolutely will. I need an expression for H. That'll just be top minus bottom. Then I need H prime. Well, that'll just be f prime minus g prime. And then I need to figure out what H prime at negative 0.5 is and use your derivative at a point command. You have a calculator. You get negative 0.6. That's a negative value. Therefore, H is decreasing. Isn't it fun how like we're locked into like new material and we're working on like the last unit of the year, and then just out of the blue they ask a question from first semester? Isn't that great? Keeps you on your toes. A lot of fun. No. These stupid people. I get like 15 calls a day telling me that my loan application is almost complete and they need more information. I'm like, I'm not applying for 15 loans every day. Leave me alone.
You mean alone?
Huh? Goodness. All right, let's go on and talk about D for a minute. I don't think I'm going to finish D through the end of the problem. As a matter of fact, I may just go on and show you what I did in third period. Is that okay? Yeah. Because let's read it very quickly and see if we can decide what type of question it is. So we have a vertical line that's traveling from left to right at a rate of 7 units per second. Does that sound familiar? What kind of question do you think this is going to be? It's a related rates problem. Isn't it fun? Isn't it fun how like when we're working a unit that's like in one place and all of a sudden they pull a question from first semester and they just shoehorn it in there? It's really cool. It keeps you on your toes. Love this class. All right. So moving left to right. Okay. It took me about 2 or 3 readings to try to wrap my head around this, but it says the vertical line is moving at a constant rate of 7 units per second. I just made note of that. Find the rate of change. That's a derivative phrase. Rate of change should make you think slope or derivatives of the area of the cross section. And we're talking about the cross section described in part C. And that area was f of x minus g of x squared. That's what we integrated. That was the area of the square described in part C. So that's the formula we're looking for. And it's asking for the rate of change with respect to time. So they're asking for dA dt when x is negative 0.5. There's our question. And this will be an implicit differentiation problem because we're differentiating with respect to t, and these are not t's. So they threw a related rates problem in with the area volume question. And sadly, I think it's kind of exciting, but y'all don't. Sadly, that's not been unheard of lately. They like to throw in curveballs. So I'm going to skip all the way back to third period so we can expedite the process and look at some other things. Here it is. So I actually worked it out all the way in third period. I'm not going to do that in here. But I found the derivative, and this is a chain rule. f minus g squared, bring the 2 down, leave f minus g alone. Then we multiply by the derivative of the inside, which would be f prime of x, but that's an x, not a t, so we have to multiply by dx dt for both of those. Dx dt is the 7 that they gave me. So dx dt is 7, so I put a 7 in there for the dx dt's, actually factored it out. And then you plug in the negative 0.5. And I didn't finish it. You can see I got kind of lazy. I still have not done the f of negative 0.5 and g of negative 0.5. So that would have to be evaluated. But that would be what you do to get the answer. And I may come back when we're reviewing for the AP exam. I may come back and look at this in more detail. But since I'm not going to do this to you on a free response quiz, so I don't know if it's worth the amount of time it will take to go over this question right now. Fair? Yes, ma'am.
So would this only be like a calculator problem? Because if they gave me something like this without a calculator, I wouldn't do it. So would this only be a calculator problem?
No, they can do this without a calculator. But if they did, they'll just give you nicer functions. They wouldn't make it a really ugly expression like this. So. All right. So how does that make you feel? Yeah. Okay. I want to look at the other free response question on the other side of that one. So this is from 2021. Yeah. And I'm going to give you about 2 minutes to look at it and read it and see what you can do with it, if anything. This is a very, very scary problem. Very scary problem. A lot of words. And one of the challenges, I say this all the time, a lot of times they give you these huge wordy prompts and very little of the big block of text is actually relevant. And we have to learn how to pick out the important stuff. The fact they're making toys and the family of functions. What is this crap? Family of functions. I don't know. The cousins or who knows. They threw in a constant, C. That's a scary thing. Students generally don't like that. Why don't you just put a 4 in there? I don't know. Each toy is the shapes generated when this region is revolved around the x-axis. So we are revolving this. So we should already be thinking there's a volume question coming up somewhere if we're revolving this. Now let's read the first question. Find the area of the region. Now that alone is a fairly nice question. We're going to do the antiderivative of top minus bottom, except this one, the bottom is the x-axis. So it's going to be the antiderivative of the function, right? Cx square root of 4 minus x squared. Right? And then they were very nice. How were they so nice? They tell you that C is 6. One of the scary things about this problem is that unknown constant. They take away that scary part in question A. Right? Now what are we missing? We need limits of integration. One of them's easy. What's this one? Yeah, you do. Don't stay. Think about it. 2. And I don't like the I don't know it, so I immediately am never going to know it type thought process. Like people looking at it and you immediately say, I don't know. How do we get 2? Yeah. We know that at this point, my y coordinate's 0, right? So let's just find out when this graph is going to hit the x-axis. When is that going to equal 0? Well, when x is 0 right there. Of course, we already knew that one. And then for the square root, 4 minus 4 would be 0, right? I need x to be 2. Technically, negative 2 works as well, but we're obviously not over there on the left side of the origin. So the upper limit's 2. Yeah. So instead of saying, I have no idea, let's try, how can I figure this out? That's a slightly more positive thought that kind of conveys the same feeling. Yes?
Finding the antiderivative of that, can you, instead of it having the square root of 4 minus x squared, can you do it 4 minus x squared to the power of 1 half?
Sure.
And then just,
And just solve it?
Yeah, literally.
So yeah, what is the method for finding the antiderivative? U sub. Okay, the product rule for parts. I just gave you the answer. Okay, the product rule in antiderivatives is integration by parts. That's not going to be on the AP exam for you. Okay, so it's either U substitution, recognition, or power rule.
I tried to do power rule.
No, you didn't. Not correctly, you didn't.
Okay.
Okay, so I don't think I say no, you didn't. Maybe you did, but this is a u sub. This is my u. What's the derivative of that? Negative 2x dx. How can I get 6x to be a negative 2? Now, there's several ways you can do this. I'm going to divide by negative 3 and multiply by negative 3. There's my du. So I say no, you did not turn it into a power rule. You could have turned it into a power rule by using u substitution because it turns it into u to the 1/2 du. So if that's what you meant, then yes, that's fine. But you're not going to turn it into power rule through like traditional algebra. How do we feel? Okay, I actually very accidentally made a mistake. Okay, where's the 6x? That's part of the du. So that wasn't the mistake. The 6x got absorbed by the du. Where's my mistake? There it is. I absent-mindedly just copied my limits of integration down, didn't I? These are values of x. Those are values of x, not values of u. So I don't want to put them here. I do like to convert my limits, though. So if my lower limit of x was 0, then u is going to be 4 minus 0 squared, which is 4. So I can put a 4. And if x is equal to 2, which was my upper limit, u is going to be 4 minus 2 squared, which is 0. Now that looks stupid because the lower limit's larger than the upper limit, but that's fine.
If you're not planning on doing
No, okay. Can I flip it?
No.
Sure.
Yeah,
I could change that negative 3 in front to a positive 3 and change the limits of integration to 0 and 4. Do y'all want to do that?
No.
It doesn't really matter. It doesn't matter.
If you're not planning on doing that, do you have to add the limits of integration?
Add the limits of integration. No, but you definitely want to leave them out. Do not put 0 and 2 because that could be held against you. I don't know if they would. That'd be very picky. But all right. So now we finish this up. The antiderivative. I'm going to ignore the negative 3. The antiderivative of u to the 1/2 is u to the 3/2 divided by 3/2, which is times 2/3. I'm going to evaluate that. I'm going to evaluate it from 4 to 0. If you're going to plug the x's back in, then you'll eventually evaluate from 0 to 2. Let's see. I'm going to, because I can, you don't have to do this, but negative 3 times 2/3 is just negative 2. And then I'll plug in 0 and 4. So it'd be 0 to the 3/2 minus 4 to the 3/2, which ultimately does clean up to 16, but who cares? 4 to the 3/2 is 8. Square root of 4 cubed. Negative 3 times 2/3. Yeah, 2 cubed is 8 times the 2 in front is 16. No, because they're both negative. By the way, a negative wouldn't make sense anyway because we're talking about area. Area is always represented with a positive value.
So if you get just a negative number, can you just make it not negative?
You can, but make sure you didn't make a mistake first.
Okay.
But yes, you can. If you look and you realize that maybe your only mistake is your limits of integration were backwards, then you're allowed to just change the sign. Are we good? All righty. Let's go on to B. It is known that they brought the C back. Can we just make it 6 again? No, because they're asking for the value of C. It's probably not 6. All right. So for this equation, they gave me the derivative. That's pretty nice because that would be an evil. Ava Claire, is that really necessary right now? Not even being subtle. Come on. Okay, where was I? Okay, that would be an ugly derivative to find on our own. Right, so it's kind of nice they gave you that. For a particular spinning toy, the radius of the largest cross-sectional circular slice. Very wordy. They're just saying the biggest cross-section. Right? So, and again, we are rotating this. And the largest radius is 1.2 inches. What is the value of C? Where would I cut that if I want to get the largest possible radius? Oh, wherever the highest point is. Whenever I'm furthest away from the x-axis, that looks to be about right there, doesn't it? So there's where I'm going to cut to get my largest radius. So that's where I'm cutting, get my largest radius. And they tell you that at that instant, the radius is 1.2. Well, if that's the radius, that also means that this y coordinate is 1.2, right? Right? Because if that distance is 1.2, if you go up from the x-axis 1.2 units, that's your y coordinate. We good? The question now, well, there's a lot of what can we do?
Plug in 1.2 for y.
Good. We can plug in 1.2. Y is no longer unknown, is it? That means that I can plug. There is a y right here, so I could plug in 1.2 for that y. Good. Now we don't have x though. Now they gave you the derivative, right?
Find what the derivative is at y equals 1.2.
We don't have a place to plug the y into the derivative. But they gave you the fact they gave you a derivative is a hint. What is a derivative generally used for?
Why don't you just move the c, or why don't you just like move the x alone and make it c? So
You can, but we're still gonna have to solve for x to get the value for c. Yeah, the derivative is used for slope, right? The fact they gave you the derivative should hopefully prod you in that direction. What's the slope right here? The slope at that point is 0, right? I could set the derivative that they gave me equal to 0 and find out the x coordinate. Yeah, isn't that neat? This is like first semester. Isn't it fun how when you're like working a problem that's just like near the end of the semester, and then out of the blue, they pull in a question about like critical numbers, and this is awesome. It keeps you on your toes, doesn't it? Okay. When does a fraction equal 0? When the numerator is 0, right? That's going to be when x squared is 2. X is going to be technically plus or minus the square root of 2, but we are obviously in positive x's. So now I have the x, and we're almost done with this problem. Now that I have x, I have something I can plug in for x. And when I do that, I can solve this equation for c. So go back to the original equation. Y is 1.2. C times x, which is the square root of 2, times the square root of 4 minus the square root of 2 squared. Let's clean that up. You want to clean it up or just solve in one step? Okay, y'all are so lazy. I love it. 1.2 divided by the square root of 2 times the square root of 4 minus the square root of 2 squared. That is an acceptable answer. It does clean up to 0.6 though. Is that evil? This is a tough question, isn't it?
I know here's the volume. That's just what I wanted to do.
Actually, volume is should be something we're fairly comfortable with. That question had nothing to do with areas or antiderivatives.
This from the AP exam?
2022. Were you born yet? 21. 22 is the first one we did. All right. By the way, the more recent AP exams, as they are released, like literally within minutes from the time AP Classroom from College Board drops them, I will start working them and record myself solving the questions. And I actually record myself solving as I read it for the very first time. So it's not rehearsed or anything like that. So you can kind of see what I'm thinking as I'm trying to process the problem. And it's a very authentic solving, not what you typically see in class where I've like done it 47 times before. So if you want to watch it, I think I linked it in Google Classroom. And I also have one for this one. I have not linked to this one yet, but I also have this one. Yes?
What's like the longest it's ever taken you to do a problem? Like, figure it out.
Now, probably, if I'm recording it, I'm also explaining it, which slows me down versus me just solving it on my own. If I weren't explaining it, probably the longest would be maybe 7 to 10 minutes.
Wow.
Yeah.
You can only do it in 10 minutes.
And y'all get 15 minutes per question. And some of them are going to be a lot faster. Like, anyway. All right, so let's look at part C. Part C. Another spinning toy. And remember, we are revolving this around the x-axis. Ooh. Volume. What are you immediately thinking?
Pi r squared,
Why?
because that's the area of the circle.
Okay, so my immediate thought I want to be cross-section, variable, which eventually will lead to pi r squared for this case. Right?
And
But-
then that's the washer.
Right. So because we are revolving this is a revolution problem. We're revolving around the x-axis. It's either a disk or a washer. There is no empty space. So your thought process should march through. This is a disk. Disk is pi r squared. We will measure the radius perpendicular to the axis of rotation, which is the x-axis. This is a dx problem. And the radius is that equation, which is the cx root 4 minus x squared. Good. And then we set that up. Pi, antiderivative of the quantity of cx square root 4 minus x squared squared. And limits of integration are still 0 and 2. Good. And then they tell us that the answer is supposed to be 2 pi. So this is a little bit of a unique question. We're not finding the volume. They tell you the volume. We have to work this out and see what C needs to be so that we get an answer of 2 pi. Yeah. I'm not going to worry about the 2 pi until I've done a lot of work with that antiderivative. The 2 pi is going to come and play at the very end.
Do you not get
You can. Do you want to do that?
Yeah.
You can do that. You can divide both sides by pi. If you want to divide both sides by pi and get rid of those. That's a little bit of help. Now, what about the antiderivative? Not u sub. Expand it. Square it out. Square it. Because it's a big product. If you're squaring a product, you can square each individual piece. So I'm going to do that. C squared, x squared, and the square root squared is just 4 minus x squared. That cleaned it up quite nicely. Yeah? And then, thanks, sir. And then I'm going to grab this C because C is an unknown constant. And I'm going to get that out of the way because it's kind of scaring me. I would rather it kind of be gone. Now, I can't get rid of it completely because we have to solve for it. And then what can I do? Keep distributing. That's 4x squared minus x to the fourth. And it actually is a fairly nice antiderivative. Now, a lot of work to get to where it's nice. But once you get to the actual integration, 4x cubed over 3 minus x to the fifth over 5. Evaluated from 0 to 2. And don't forget, there is that c squared out here. So c squared times, plug in 2. What is 4 times 2 cubed? 32. Minus 2 to the fifth is also 32. Minus, plug in 0. And gives me a couple of zeros. Always plug in the 0 to confirm it returns zeros. Every now and then it does not. Good. And now I can bring back way up here. Now we canceled the pi, so remember the pi's gone now. All of that's supposed to equal 2. And we have to solve that for c. How hard is that going to be? Not at all. If you get past the ugliness of it, I'm going to divide. I'm going to leave this as ugly as I can. I'm going to divide by that fraction, 32 thirds minus 32 fifths. And then we'll square root both sides, and we're done. Yeah. How do we feel? Abused? Yeah. That was a tough problem. That was a very challenging problem. Very atypical question. Yeah. They did not ask an area volume question last year. I was going to try to give you the 23 problem today, but I looked back and there actually was not one. It's unfortunate.
Does that mean that it's more likely to have one this year?
I think they probably will put one this year. Yeah. But they will always, one good thing about area volume is, well, except this is the one year that was really atypical. Question A really, it had U sub, but A wasn't terrible. A was, can you get past the ugly presentation of the problem? Can you get down to the core question? And if you can, that really helps out. I did give you at the beginning of class 2 free response questions. One of them is from 2019, and you should be able to find the solutions to that one pretty easily. The other one, and I think this is the first time I've given you a question from this source before, but in AP Classroom, they actually have practice free response questions that I can assign to you. They're not true free response questions that were on old AP exams. They're just kind of recreations to practice with, and they're pretty lengthy. This one actually has 6 parts, and this is kind of a neat question. Questions A and B are both asking about the area. If you were to find that area, what would you do? Big picture. Okay, if you did top minus bottom, what would happen? It's fine, but you just have 2 different tops. So you have to do 0 to 4 and then 4 to 6. Or, what are you thinking, Evan?
So is like the first thing is A, a dx problem, B is dy. So you have to do
Yeah, so now they don't do that on the AP exam. On the AP exam, they will simply say find the area. Because this is a practice problem, they're trying to get you to train yourself to be able to work with both. But yeah, if you look at A and B, one of them says do dx, the other one says do dy, right? Do dy, like why duty? Because my family had diarrhea so bad. I don't know. Too much? Yeah. Anyway, anyway, one good thing about these is in AP Classroom, and I did assign this to you. It's Unit 8 Level 3 problem. I didn't look at. I glanced at 1 and 2. I kind of liked this one. In AP Classroom, they actually have video explanations of each part. So if you go to AP Classroom and open this up, you can see somewhere on the page, you should see a link to a video explanation. It's just another teacher somewhere that College Board probably paid to give an explanation. And so that's one good thing about it. And it's 6 different videos. It's not like one long video that you have to scrub through. Yes, ma'am.
If it's respect to y in this case, would you just convert your things to y and the example?
Yeah, you have to. Yeah. So for part B, you have to solve those equations for x.
I didn't know if you had to do like top minus bottom.
No. If it's dy, it's always right minus left.
So
And then if it's dx, you would just do right minus left.
No, top minus bottom.
Oh,
there's 2 tops.
Top minus bottom is always dx. Right minus left is always dy. And then you've got known cross sections. Number D, revolve it around the x-axis. E, revolve around the y-axis. And F is a horizontal line divides into it. So it's a good question. I liked it. So that'd be good to look at. The question on Monday will be a calculator question. So I think that's a good thing. Is it? Third period seems kind of happy. I haven't chosen the question yet, so hopefully I can find a good calculator question without having to make one up. So there are those. We will do this Monday, and then we'll review. Remember, test is Wednesday, Friday next week. If you're going to be gone Friday, which I know Bend is going to be gone, is that correct, Lilia? If you're going to be gone Friday, then you can take it early, and I would encourage you to take it before spring break because you won't remember it when you come back. And then after spring break, it's hit the ground running with AP review. Yeah.